Hello and welcome to Live Coding with Gerph. Yes, again, I forgot to press the button properly, so you've got a bit of cut-out titles there. No problem. Anyway, so what are we looking at today? We are continuing with the system introspection built into the kernel, which provides basically a set of stub dummy values just so we've got some interface to be able to get out information from the system. Not particularly complicated, all relatively simple, so we're not going to be seeing anything too scary in this work. Can't see me. Oh, that's a good point. I'm not visible. Why am I not visible? Hello, camera. Camera not there. Disconnect the camera. Reconnect the camera. Come on, camera. It was working when I tested it earlier last night. Disconnect. Come on. Plug in. There we go. You're plugged in. You've gone red. Oh, and there we are. We have a picture. Awesome. It's a little bit dull, but I think we'll cope. I think it's kind of how I look, is a bit dull. That's a little bit of an aside. Technical difficulties are a little bit, it's a bit frustrating with this, but I'm not sure. I may just have to play a bit more. Hi, Alan. Yeah, we were here again. Right, so what I was trying to do was explain where we were. So we started doing some bits on this and mostly it's working okay. In the meantime, since last week, I have upgraded the operating system and my editor. So it is possible that things will look a little bit different and I may end up cursing things. If they're not quite working. Look, pointers look different. They're all smoothed and edgy. They're all like got nice corners to them, which is kind of weird. But I've still got my blue and cyan pointer, so that's nice. Anyway, right. So what are we up to? If we have a look at our status page, we can see here what we're trying to do, and. So we've got a little way through the functionality. Some of the SWI done, and the vectors kind of handled. So first thing was we've got the OSByte calls worked on. We've got all of these read sysinfo calls are started on. They don't do anything particularly useful, but they're started on. We've got to do these OS memory ones. We've got to add in these extra ones for the new read sysinfo calls. Fair enough. And then there's some platform features and memmap entries. So what I'm planning to do is the read sysinfos, we can sort of finish those off. That shouldn't be too hard. And then we'll have a look at the memory. No, we'll look at platform features, then we'll go into memory, because we don't really have memory at the moment. We don't have any of the other things either, but memory in particular we don't have. Yeah, so we'll see how we can get on with that. So platform features is the first thing we're going to try. Let us give this a whirl. I suspect this is going to be reasonably dull, but we'll have a look. Projects, RISC OS, and in here we've got loads of things, of which Kernel Introspection is the one we're working on. As we have a look in here, we've got these, and we can see that we can build things. Hey, build things! Come on. I didn't mean to build it 64-bit. I'll build it 64-bit. Fine. Let's build the 32-bit version instead. Right, we've got a 32-bit version working, or building. So let us have a look. So we need to implement OS platform features is the next one. So let's add in the SWI call. So the way we're doing this is we're providing SWIs in a module that can be used in place of the real calls, and we're also providing replacement calls as well. So platform features, SWI, platform features. So you can turn one or the other off, and it'll choose which ones it wants to use, or you can choose which ones it wants to use. So I want platform features, and we've got that on there. I see. So we've actually been having a separate file per implementation. So let's create OS platform features here. There we go. Right. Header. Ooh, my header works. You may remember, if you were here last week, that I was cursing the fact that I hadn't got the date inserted. Now I've got the date inserted. Yeah, I'm really clever, and I can work out how to do that. That was really hard. Implementation of the OS platform features SWI calls. Right. And to do this, we're going to have include RISC OS/OS platform features. Let's get the header imported. We're going to want SWI calls, and we're going to want, so we'll probably want kernel as well, don't we? Yeah, so there we go. That's some headers, and then we just want to include the system call. So what I'm going to do to get the system, and potentially this as well. That's handy. Let's get the prototype for this. So, right, okay. So, let's just get the beginning part, the debug part, and then the dispatcher is at the end, isn't it? Here we go. A big long dispatcher with a switch statements in here. I'm not sure that switch statements is really the right way to do it. I did it as a dictionary in the Python code because it's cheap, but for now we'll just do it this way. It's fine. It's fine. Platform features, and we start out saying that it's not implemented. Print out some debug to say what we're calling it with. As usual, the entry point is the reason code is in R0. And then we want to replace all of these with actual calls. So let's find out what we have. So here, RISC OS kitten platform features. There we are. Oh, we've only got 2 defined in the system header here, so the other ones we'll have to add in. That's not a big deal. But we do have 2 of them. In fact, what we'll do is we'll actually add the new ones as well. So these are the old ones. Add the new ones. So actually, the easiest way to add this is probably just go and have a look at Pyromaniac's entry. So Pyromaniac. Oh, I'm doing well on the typing today. RISC OS constants platform features. There we go. Oh, great, thank you for that. Oh, it didn't work either. Why did it put it into another blooming window? Not in the one I'm already using. It's not very helpful. It caused me to switch all over the place. So, these are all the platform features calls. We've got them defined in here. So, let's just stick them in here. So we know that these 2 are defined, but these ones aren't. So we'll just stick if nadef os platform features CPU vectors location, and then we'll define all of these. Hash define. Nicely lined up. There we go. Define all of those. Eventually I'll add those to the main header, but I haven't got around to it yet. So we've now got an extra smattering of these, which we can add in here. All right. And we're going to want to use them as well for defining the function names. So I'll put them up there as well. So here we go. Case, OS platform features, whatever. And then a break statement. And they've already set as not implemented, so we just want to do equals platform features underscore and then that bit. Oh, in lowercase. Oops. Okay. Lowercase, there we are. And we want to pass in the register block. Yep, that sounds good. Oh, do you want to pass in the private word as well? Did I pass in the private word last time? I didn't, I just passed in the registers, so that's all we'll do this time. Okay, so there we got those, and that's pretty much it. Oh, as I've actually got the multi-selection done here, I can actually copy these. Yeah, this isn't going to work quite so well, is it? Oh well, doesn't matter. We'll make it up from here. It's fine. Right, we'll just create the definition of them here. Oops, too many. I don't know how to undo an extension of the multi-selection, multi-cursor. Kernel os error, star, and then platform features underscore that in lowercase. In lowercase, please. Thank you. Bracket kernel swy regs star. Yes, I'd copied them because I wanted to put them into this this block. Because if I'd copied them, I wouldn't need to do that magic convert the definitions I'd had previously. But because my cursor was split, it would have ended up all over the place and it would have made a mess of things. So I couldn't do that. But now that we've got each individual function defined, we can now not implemented. We can now have each of them return their errors, and we can implement them independently. Error. There we go. Right. Platform features. That looks good, and I think we just need to change this one to say platform features. I think actually there's a proper error code for bad platform features. Discuss kitten new errors, I think it's called. Platform. No. Features? I thought there was a dedicated error code for bad platform features. That's rather frustrating, to be honest. Discuss resources, lib. I thought it was in lib. Is it in C? Oh, it's in export C. RISC OS H, new errors. Bad. Maybe I could have just searched this outside. Parameters. Bad filing system, key, address, string, alias string, param string. Yeah, we did all those in system variables. Bad commands. Module reason codes. Module swise, filing system. Yeah. MMU control has some. That's fair enough. That's all evaluate expression stuff. Bad to the bones, just Dave. That's definitely me. I'm definitely a rebel. Sparsity, bad time, bad parameters. Bad read sysinfo. Oh, there's a dedicated bad read sysinfo error. Oh, we should probably be using that, shouldn't we? Oh, okay. Well, since we've just found it, let's put it in. Come on, it's going to be bad read sysinfo, and it has error number bad read sysinfo, And the string, we may as well actually have it be the string that's there. Why not? Since that's actually quite a fair call. And then we can just substitute that into where we've got not implemented. I mean, in theory, probably all of them should be returning bad read sysinfo. Doesn't matter. We'll leave that for now. So that's doing that. I've left an extra comma on the end. There we go. Not available. Mode selector flags, bad handle. Memory slot. I think we're in WIMP now. This is no. Maybe I'm just misremembering. I was sure there was something. All WIMP calls. Bad network. This is eConnect things. Yeah, so eConnect operations there. Domain. Yeah, it's all filing system ones. Buffer size, file type. Bad podule. Yeah, all in podule stuff. Yeah, I think I'm just going to have to... Oh, what was that? Read info. That was printer, wasn't it? That's right. Rectangle, half term. No. All right, give up. Fine, that was unhelpful. So read sysinfo is there. We'll just have to use not implemented then. Leave it as it was. But we should change it to be a bad platform features proper call, I think. Okay, so that's platform features, the file implemented. We now need to add that to the make file. So here we go. Boss platform features. And then we need to make it get registered with the system in here somewhere. Not that, that's test code. Sorry, getting confused. Platform features in the module code. Yeah, here we are. Registering the SWI calls. Here we are. So this one we need to add in platform features. There we are. And the definition of the call here. And then we'll see whether it builds, shall we? Build for RISC OS. Apparently I didn't save the read sysinfo file now. Let's just save that as well. Right, what do we get broken then? Undeclared name. I didn't include modhead. Modhead. Which has got me error definitions in. C platform features has got a printf error. Oh, I didn't include studio or studlib for that matter. Studlib.h and studio. There we go. Right, and then we've got some other errors coming out of CMunge as well. I think this is going. I'm going to have to do something clever with this to make it link to it, aren't I? But line 89. That's not at line 89. You're lying. I mean, line numbers have all gone funny. That's rather sad, isn't it? Oh well. I'll need to debug that in CMunge later, I suppose. But right now, we want just look for the read sysinfo message, I suppose. Read sysinfo. There's that one. Is that because it didn't include it? I didn't include the errors. Include RISC OS /new errors. Really, we should rename new errors to be something more sensible. And I've retained the same name to how we do things previously. Hello. I'm sorry. I'm going to butcher your name, I'm afraid. Sumayelarot Saka. And Hermant Rawat, hello. We get a lot of people from non-RISC OS community. It's lovely. So, yes, what we're doing at the moment is we're building this module. So just for the people that have just joined, I am creating system introspection for the kernel to read information about the what's going on in things, and hopefully we'll be getting something useful out of it. This is all for RISC OS, so although I'm building things on Mac OS, this is for an operating system that doesn't run on Mac OS or Mac machines. It runs on other ARM systems, but what we're doing. So I've got a bizarre differing redefinition of module date here. Why is this? Is this the... This is in COS byte. Let's have a look. Is this because we've got them around the wrong way? Should that be around the other way? It's rather strange. Inventing entry platform features. Oh, that doesn't look right. Platform features. Oh, that probably means I haven't defined the entry point, which is what it's telling me, yes. So I need to define that, not slide decoding table. Here we are. The veneer for the entry point needs to be... Ooh, what did I just do? I pressed some key sequence and it didn't do what I was expecting. Oh, I pressed Control B rather than or Command B rather than V for paste. Platform features. There we go. Build again. Error capable argument not permitted. This was working. Didn't I have this working last week? Oh, that's because I left a comma on the end of it. Error handling is terrible sometimes in CMunge. There we go, we built. Right, so got signed constant overflow. Yeah, not gonna worry about that. We'll leave that one alone. But this is now built. So if we go into, oh, I'm still inside the shell. PyroDev, common, load module. There we go, and drop into basic. Thank you. OS platform features 0. This should give us an error. It does, and it tells us that it went into our code. So we now have some bits here. Hello, Timo. Okay, so we've now got some stubs for platform features. We need to add the file. Add os platform c/os platform features. Thank you. And if we have a look now, we should see there's a number of change files and OS platform features. So let's commit that. Add stub for OS platform features. At the moment, we only return errors. That's it. Yeah, not what else I can say there. There we go. Right, so now we need to look at how these are actually implemented, what they actually do. And if we have a look in here, we'll start out with read code features. So what we can do is we can define the header that tells us what it actually has. And the easiest way for me to do this is to pinch it from Pyromaniac. So if we look for platform features in here, platform features py, there's the SWI call, and we look down for code features. Here we go. We can now pinch this section and dump it into here. Oops, I need a little bit more room there, don't I? That's not a lot of space for writing things. Right, so here we are. Ooh, IRQ trigger function is returned. that's going to have to just return because we don't have anything to do just yet. But we can still do it. It's not a problem. Actually, I have a feeling that's meant to return 0 if none is needed. I have a feeling that's what it's meant to be. Let's have a see, shall we? Just drop back into here. RISC OS PRM platform features 0. No matches. Well, that's disappointing, isn't it? Okay, OS platform features 0. Sorry, apparently I have to even specify it that this is RISC OS as well. Yeah, I don't want to know the flags, I want to know the actual call. Code features, or 0 if no routine is necessary. Let's paste that into there, shall we? Because that'll make it a bit easier for us to do. Right, so what we can do here is we can define uint32t. Let's make this a bit bigger so we can see. Ooh, no, I didn't mean to do that. Stop it. Go back. Thank you. I meant make full size. Thank you. I clicked to create a new file. Flags equals 0. Oh, we still want to keep that there, sorry. But we can set it to null now. Right. So we've got a whole bunch of flags here, which I have forgotten the names of. If I just toggle myself back to here, here's the names of them all. Platform features code, all of these ones. Oh no, all the way down to here. Lots of different ones here. Okay, and right now we're probably just going to have a bunch of these being. We can delete these, can't we? Oh, I've deleted a bracket as well there. That was silly. Get rid of those. Oops, get rid of those. Get rid of that line. All of this lots can go. That line as well. And all of these. All the blank lines can be gone. Okay, so these are the particular flags. And what I'm going to do is really simple. I'm just going to go through all of these. Oops, all of these. I've done it again. Hit the end here and do flags or equals everything. I'm also going to just quickly copy these up here because I think some of them aren't defined. I have a feeling that some of them aren't defined in the system header. Sorry, so there's some questions on here. What we're learning now? What we're learning now? Yeah. Yes, so what Dave said, what Bagger Spanner said is I'm trying to port some RISC OS components. So in RISC OS Classic, all of this code that we're implementing now is implemented in assembler. It's a bit difficult to work with, is assembler, and it doesn't work on anything but original ARM32-bit, ARC32. So what I'm trying to create is a similar implementation but written in C. And we've implemented it in C so that we can then have it more accessible to people, more understandable, and much easier to modify, maintain. So that's the goal, what we're aiming for right now. So a lot of this is just take the code that was originally there, or the defines that were there, and make an interface that looks similar and just returns some sensible values. They may not be completely sensible, but we can at least make them vaguely usable. And that will mean that then we can update them as time goes on to be more flexible. And that's all we're trying to do, is just trying to get some similar interface so that we can advance the operating system by using a modern language. I say modern because C is not modern. It's just that C is more amenable to most of the things that RISC OS users are used to. I've got some parallel work that's making Rust work. And Rust would be a much more useful system, but I haven't spent much time on it. Paolo has been doing more things with that, and that's up to him to be able to publish some bits on how he's doing things with that. But right now, this is where we're going with this. I hope that some of this is useful and interesting to people. Whether it's not, I don't know. Whether it is or not, I don't know. But yeah, we'll see. At the moment, yeah, we're just basically giving everything some dummy values to return. And in some cases, we don't need to actually make them dummy. We can make them real. We know we don't have any IRQ triggering function. Okay. Well, C is more flexible for people. Rust is a much better language for writing things these days. If you want more people to start being involved outside of the RISC OS community, Rust is a much better way to encourage them to do things. C has a wider audience, but a lot of people aren't wanting to write anything new in C. So again, this is trying to bridge a gap between the people that are doing things in RISC OS and the people that are outside. So yeah, I don't know Rust very well, like hardly at all. So that's one of the major reasons that I'm not doing Rust so much. I will need to learn a lot more, which means that any other guidance and help from Paolo and others would be very, very well taken. Right. At some point, I do plan to be able to write RISC OS modules in Rust, but at the moment, you can only write them in C with Pascal or Fortran as your linking options, because clearly Fortran and Pascal are good choices as well. Sorry, slight digression there. Let's continue. Right, so if def RISC OS 64, if we're in 64-bit, synchronized code areas is required. Hardware trigger will be necessary. I don't know. Hardware vectors need to be 32-bit mode. That's not relevant. Not relevant. Data aborts are early. Not relevant. Separate cache. Operating system is 32-bit. Well, it's not. It's going to be 64-bit. 26-bit unavailable. CPU has blah 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 blah. Cannot disable dcache is going to be true. Extended small pages not relevant. No. DWB. Can't what DWB stands for. Broken aborts. Well, hopefully they're not broken. It's not an X scale. It's not got a JTAG. It doesn't have high vectors. It has a different style of vectors. Larger physical RAM. At the moment, it won't have. New physical pages will mean that we're not actually handling the memory side. Invalid reasons are safe is going to be true, however, because that's a marker to say that it's safe to call the other entry points. All right, so that is, let's make a note here to say this is approximately correct for RISC OS 64. Options that are not valid for ARC64 are ignored. It's possible that actually we should have a flag to say what the operating system is here, but they're starting of bits to be able to represent that, so it can be handled in another entry point, which I believe is platform features 64. So that should give us, on a 32-bit system, 32-bit RISC OS, has separate caches, 32-bit, is 26-bit unavailable, yeah. Just set every single flag. Oh, set every single. That was not right. Single. Every single flag. There we go. Right. So let us toggle that back to there. No, let's not toggle it back to there. Let's just resize it up a bit as well. Up we come. Here we are. And then try build. Oh, I can try building it here. Ooh, my break timer is kicked in. No, we're not doing breaks. Disable that for a few hours. I've just installed break timer because Taylor reminded me it would be a good idea. But of course, whilst we're doing these sessions, I'm not taking breaks except at the 1.5 hour mark. So let's try building it. Build. Yeah, that was inevitable. So a lot of these are not defined in the main header, so I'm going to need to add some of these. Everything from separate caches onwards. So let's do this. They're all defined. Where's separate caches? Oh, it's there. Yeah. So let's do that. So if nadef that, and then put some defines in for all of these. And I should add them to the standard header, but I haven't got around to it. I could import the standard header that's exported by RISC OS 5, I suppose. That might actually be more sensible. Oh, this is, yeah, big full screen, please. Bit bigger. There we go. Bounce, bounce. Oh, no, I didn't mean to do that. I meant to go like this. Tab. And then delete. There we go. That's lined everything up nicely. And delete everything from the end. I'm getting used to clever things I can do with the editor, but there's still a lot that are a bit more. I've got to get used to yet. Right, let's build this. Oh. Okay, well that's interesting, isn't it? I'll temporarily just comment those out. As I've upgraded my editor, I've now got these things here which actually tell me things at the side of the thing rather than they used to pop up underneath as phantoms, but I've now, because I've upgraded, we've got a slightly different format for them. Not sure I'm as keen on it, but hang on, differing the, it's commented out. Are you not? Did I not save that? Are you a line out? Why are you a line out? Line 39, differing redirection definition, but it's on I wonder why that is. Sorry? Yeah. Oh well. We will just have to cope. I haven't included student. I also clearly don't remember what I've said. Right, it's built now. Good. So we've got this entry point now returning something. Arguably, we should actually have these call into another function to say what are the values for this. But for now, we can leave it as it is. It's got a structure that we can start moving things more nicely. So, read MMU features. We won't have any MMU features if we look over here. It's a RISC OS select only feature and we can't control them. So what I'm going to do is just leave it as not implemented, but I will document what its entry point is. So if we have a look in here, OS read MMU. Oh no, it's not. It's read. It's platform features. Sorry. MMU features select. Dun, 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 no. Oh, well that's disappointing. Try RISC OS, shall we? Otherwise I'm going to have to, not there, not there. Yeah. Well, that's disappointing as well. RISC OS select. Let's just see if we can actually prod it into showing that link. No, that's not it. Oh, I definitely remember documenting it. Okay, well, in which case we'll switch to this and we'll look in here and pinch the code MMU features. Oh, it's not even implemented in Pyromaniac, so there you go. In fact, the next one that's implemented is 21, which is read cache information. And looks like we've just gone, nope, not supported. So let's just return that, shall we? Here we go. Cache information. It's quite a nice call, really. It's quite well thought out. Cache type none. Cache type instruction cache. Have you? Well, I'm not sure what that means. Oops, no. Oh dear, no, wrong Windows. There we are. That's the right one. And then the implementation here was very, very simple. Making them configurable would be a nice idea, wouldn't it? Oh, I deleted the error. Start out with not implemented, and we'll put this into a switch. One of the interesting things about Python is it doesn't actually have a switch statement, which is frustrating for cases like this. I mean, it's not terrible, it just, you end up writing lots of if-else, or moving things into dictionaries for dispatch tables, which is fine, just it's a little bit odd as a way of doing things, when you're used to having switches anyway. R to R bracket 0 equals that. Actually no, let's just go to the bit here. We can change that to be // Oh, that didn't. Oh, well, fine. We'll put the semicolon there and then we'll fix up the one entry we've got. There we are. And then we'll do them here. Cache levels not supported. So in that case, default turn. So, oh, no, we need to break there, don't we? Otherwise we're going to fall through. Error. Actually, no. What we'll do is we'll leave that there, and we'll set the error to be null for this. There we go. It's nicer, isn't it? Because then we only ever return with null if we say we should. No dcache, no key cache. We have an iCache. That's apparently flags. Probably need to have them defined. Yeah, okay. All right, next thing, CPU features. Jump back. Oh no, not that one. Let me go back in my history. Not that. Oh, I really don't like Chrome. CPU features 22, sorry. And this is basically just features that are present for ARM32. So a lot of these are just going to be irrelevant to us in 64-bit. Not that, this one here. Do we have a CPU features? We don't even have it, so we're going to leave it as not implemented. The next one along is describe CPU architecture, which is code 64. This one describes CPU architecture, which is documented here. And that has a static block describing it. I'm probably just going to have to copy that static block because it's going to be interesting. Yeah, but let's define the entry anyway. Here we go. Describe CPU registers. Number 64. So at least this is going to be relatively easy for us to define because we can actually just provide a static block that describes it. And I'm pretty sure I already defined one in the debugger module for the 32-bit environment. So let's just quickly have a look at the debugger module. $/debugger. Oh, where did I put debugger then? Is it in external? Oh, I don't know. External ports debugger. There it is. I need to move that. It's in the wrong. Well, it's not in the wrong place, but it's not exactly ideal. Right. Introspection calls. This is the one that does things. Exception area. Describe CPU. That's the actual call. And then we've got default CPU registers for 32-bit, which is in here. Oh, lovely. That's a nice table, isn't it? Yum. Let's copy it and then we'll expand it out later. In fact, we might as well copy. Oh yeah, we'll copy that file. Yeah, so there we go. There's a static block for the CPU features. So you can see there's a number of strings in here and things. This is actually built up automatically by the system, but we'll have to have a better way of handling this. 1C800. That's a bit flag, isn't it? It's a mask of where things live and stuff. Yeah, probably gonna have to have a little generator to create this table. And we also need one that defines things for 64-bit as well, which we may as well also have a similar table. Let's have a similar table for 64-bit. Dummy for now. Pointer to CPU architecture and register block. Here, and then a list of registers, and there we go. All right, so that's the definition. So all we need to do is just return a pointer to that value then. If def RISC OS 64 register 0 is, oh, I've forgotten what the variable was called. Default. Yes, it's going to be default 64, and then there's going to be another one that's going to be called, oh dear, fingers. For the 32-bit. That's it. We just need to actually make them valid now, and that needs to be 64. If def RISC OS 64, and this one wants to be returned only if we're in 32-bit. It's a little frustrating that it's not easy to detect 32-bit other than to go, are we not in 64? But maybe we'll rethink that in the future. If not defined 64 and defined RISC OS. There we are. Okay, so now we've got a 32-bit block returned there, and we've got a 64-bit block that contains garbage. So we need to get a 64-bit block out. How do I get a 64-bit block? Dum-de-dum-de-dum. I think I know how to do that. Yeah. I don't need that anymore. Let's move that one out of the way. There you go, you're out of the way now. And that's the Pyromaniac window. Let's move that out of the way as well. And what we're going to do is copy project. Ooh. Oh, it's not, it's an external port. So I'm going to grab a copy of PIC-OC, RISC OS version AF64 PIC-OC, and copy it into here. And then what we're going to do is we're going to go and start RISC OS 64 with a big application size. Go see interactive, please. And now I want to do OS. Oh, what is OS platform features? Ah, slide number 6D. OX 6D. Input register. Don't need any input register. We just need to know the output registers. There. And that needs to go into. Oh, I haven't defined a variable. I'll define a variable in a second. Reg. No, this is CPU reg. It's undefined. Correct. It is undefined. Int CPU unsigned int CPU reg. And then repeat that, and then we can print it out. So very tacky. Oh, why did you do that? Oh, I didn't tell it what call to make, did I? Oh, stupid. I do need to pass in a call number. I need to pass in the call number 64 to say I want the registers. Invalid operation. Huh. In 0, out 0. Does it not know in? Or surely we can't be not handling or. How weird. That's definitely a bug in PIC-OC. That makes it a little bit more limiting, doesn't it? Yeah, I'm gonna have to look into that. But regardless, that will have done the right thing. It hasn't done the right thing. Oh, that's quite frustrating, isn't it? It's either that or, just out of interest, is it because this number is coming out wrongly? That doesn't look right to me. That looks very wrong. Oh, that just doesn't look right at all. What's going on here? I wonder if I've made a mess of the definitions for in and out. Let's go out bracket 0. Semicolon. In bracket 0. As an integer. Oh, that doesn't look right. Oh, that does not look right at all, does it? I'm going to have to do these by hand, I think. Oh, obviously PIC-OC is not quite working as well as I would like. Oh dear, I'm sure I'd used this before. No matter. So, temporarily, let's work out what those values are. Because, yeah. C:\h dot swise pipe through less. Yeah, there we go. So out registers are 1 shifted left 31 going down, and in registers are 1 shifted left register. So the value I'm going to want is going to be, oops, a little bit bigger please, 1 shifted left 31 or 1 shifted left 0. That's a big number. Give it that number. Where's my SWI call? Thank you. This was meant to be so much easier. Right, now we can print out the CPU registers and see what they come out as. Right, that is an address we can work with. So we drop out of PIC-OC and we can do memory I 3817004 plus 300. There we go. Lots of values. And it's still going. It's actually going. It's still going at 300. So I need to go and push it up a bit higher. Let's use 800. Ah, there we go. It finished when it got into this bit here. Oh no, that's register names, and that looks like the end of it there. So if we copy that entire chunk, whoops, gone a bit far. So clearly this is, yes, 800, that's right, is not a good way of defining it, and we should have another way of representing the CPU registers in the future. But for now, this will do. Right, I need to make all of this into C code. There we go. Oh, no, I didn't mean that. OX, and then this number here. Get rid of that bit at the end, we don't care about that. Put it there, and then we'll put the text string in comments here so we can see what that string is. So, that looks wrong. That first value is coming out as 0. I don't think it should be 0. I think it should be something else. Right, there we are. That's the block that we're going to define. Yeah, I think that's wrong. I don't think that should be 0 there, because if we look at the definition here, it says value 0 at 0 should be the architecture identifier, and we should be returning 1 in there. I think that's broken. I'm going to put a 1 in there. The next two are minimum instruction, maximum instruction, and then total length of the register block, which currently says 114, which is also garbage because this. Oh no, that's the register block, not this table. That's right. So yeah, there's definitely stuff in there that's not great. Righty ho, let's. We've now got that number corrected, at least. Let's try and build it and see what happens. Ugh, it's very, very tiring, this. Red Eye Developers says another Linus. No, I'm definitely not Linus. I'm neither as clever nor as caustic. Well, I hope I'm not as caustic. He can be very opinionated. Well, so can I. Yeah, well, that's something for the future, I suppose. You can decide whether I am more Linus-like or not. Okay, so I want to build this, don't I? RISC OS ammo, build it. Yeah, that didn't work. Undeclared name cache level, registers. Oh, a whole bunch of things went wrong there. Let's build it here and we can jump through the sources. Oh yeah, we didn't actually define that as an integer. Declare it as an integer, and oh yeah, this is still in Python style. So there we go, that's now defined. And it was also complaining there was a missing semicolon there. More like RMK, Russell King, I'm assuming that is. Don't actually know who RMK might be otherwise. Go on, Dave, tell me. Excuse me a second. Hello, I'm back. The Flagus Panel says that both myself and Russell King were at the same show, and apparently we looked very similar. Oh my God, there's two of them, said Matthew, apparently. That's reassuring. Clearly, I don't remember. Too long ago. Or possibly trying to block out the memories. Yeah. Error. Implicit cast of pointer to int. Well, that's fine. Yes, we do want to do that. We should be casting it to uint third duty. Sorry, we're going to have to do that for both of them. Missing endif. Where did I forget to endif things? That's the big table. I forgot to endif this one. Right. Build. We will create something that generates this table. Right, it is built. So. Yeah, there's not a lot we can do with that, really. I mean, it should be like quite usable. So if we build it, this is the 32-bit version. Minus 32 common and load module comes. There we go. Drop into basic. So we should be able to do sys os platform features 64 to CPU regs, and then tilde CPU regs 705484 plus 80 will do. Yeah, that looks like the right sort of table. Hello, RISC OS UK as well. We've got like 6 people watching us at the moment. It's shocking, I suppose. Yeah, so that table's there. Right, so git status. Yeah, we've implemented that now. I need to sort out Pico C at some point. I'll sort it out. So we've added some implementation of OS platform features. Added dummy implementation of OS platform features 0 and 64. Platform. Yeah, I imagine people have got things to do. Yes, that's quite likely. Talia did suggest that it would probably be a quiet session, this one. So I think that's probably more likely to be part of the reason. Well, that people are having things to do rather than that Talia had suggested that. I mean, I'm sure the people do listen. Has to go. Alan has to go at 3, so remains. Oh, okay, it's fine. And yeah, I don't always post on the rule forums to say that I'm live because nobody watches it, looks at the forums regularly anyway. But yeah, if they do, that's fine. To read the code features is now returning some values, all the values actually, in 32-bit and a restricted set for 64-bit. OS platform features 64 return. Oh, and we also did one of the others, didn't we? Did the which one was it? Code feed, the cache details. 21, which is 33. 33, it tells me there. 0, 33 and 64. So OS platform features 33 returns some dummy values for the cache details. Returns a static table for 32-bit and 64-bit in an ugly table. There we go. We'll have to do something clever with that. I'm just wondering what the best way is to do that. But we've now got some calls that are implemented. We can push that code, and in theory it should build. The other bit that I was saying was wrong was that those platform features were returning the wrong thing. So let's have a look at the actual Pyromaniac code, because this is clearly not correct. So this calls into a resource called register dump info and gets the descriptor. It's entirely possible. Where that'll be implemented, probably in Pyromaniac / CPU registers. No, it'll be in CPU, I think. Emulators. It's probably in emulators. So is register info in here? No, it's not. I may have to just search for it. Dun, dun, dun. Actually, it might even be in the RISC OS side of the code rather than the emulation side. grep for register dump info in project row Pyromaniac RISC OS. Nope, not in there. Pyromaniac then. Oh, so actually we did get some people joining us from those posts. That's really interesting. I wasn't doing it because I thought, well, people will have seen the announcement. Thank you very much. That's very handy. Thank you, RISC OS UK. How is this not being found? It says it's going to a thing, but it's not actually finding it in any of this code. So how is it defined? Register dump info. Is it case insensitive? No. In RISC OS insensitive. Register dump info resource. There we go. It's in OS platform. It's in the file I was looking at. It's in this file. Register dump info. So this is the code that generates that table. Oh, well, look at that. It's hard coded to only ever describe it as 32 bits. That's really dumb. Really dumb. Especially as we should actually be reading it out of the probably out of the architecture. So we must have that, surely. We must have it in one of the architectures. So row registers, excuse me, registers, emulators, registers. Are they implemented in here? I'm not actually sure. I don't know how this is implemented anymore. Let's have a see. ArcReg, not in there. Not in there. Not in there. Self RISC OS registers. So it must be. We'll do another grep. What the heck? It was in the registers.py. I couldn't even see that file. Registers.py, there we go. So arcreg is that. And I think, no, we don't return, there's an arc there which says what the name is, but we don't actually return the architecture. But surely the emulator returns the architecture we know the emulator, we can do. Yeah, that doesn't have it either. Yeah, okay, well, in which case then, let's just go back to here. Arc equals deep if self.row.mu.name row.mu. No, that's not the one I was looking at. There we go. That's the check I want to use. If it's ARM, do that. Otherwise, do that. There we go. Right, now this particular bit of code that generates the descriptor can probably be used to generate that table, because that's all it does. I can probably lift this code and make it into a self-contained bit of code that we use in there. Sorry, Dave, I just noticed Dave saying, Sprite the cat just woke up and came to play with your mouse pointer. Yes, it's a very big mouse pointer, so it's highly visible. Although, don't you have the same set of colours, Dave? So it would have recognised them. Anyway, yes, so that table we can probably use to generate it. And now we should be getting the right values out of it as well. So, digression aside, apparently Dave does have the same colours as me. In fact, I have a feeling he gave me the colour numbers to use, and I put them in. I typed them into the RGB values. Right. Yeah, so we've now pushed that. That's good. We don't have to worry about Pyromaniac anymore. I will fix up its code later. No, don't go over there. Go here. Sorry, getting distracted by things. Dave has just posted a little picture of the cat watching my video. That is so very cute. And probably they're just as bored as the rest of you. Cats love kernels, apparently. I am easily amused. I am easily amused. But that is quite fun. I wish to ask permission to use pictures of your cat. May I use that to advertise the channel in the future? Even our viewers' cats enjoy the channel. Right. Testing. That was my next thing. Dave says, sure. Brilliant. We will do that. Testing. Yes, we're going to do some testing now because we've added some new read sysinfo calls. So platform features calls. So if we look in here, we've got the expectations out of this, and we've also got some assembler code. We need to copy some more assembler code over there to do the testing. That's actually the check I want. Oh, why do you do this to me? Oh, I'll go back there. Still not working. Drag. Thank you. Taylor has finished wrapping up the Christmas presents. I have yet to finish wrapping mine. I've got about 4 or 5 still to wrap, I think. It's fine. I will get them done probably this evening, I think. Well, either this evening or later this week. So I want to have a look for the platform feature. Platform features, cache info, code features. Ooh, these are all 3 of the ones that we want. Excellent. And what else do we need? No, I think that's it for now. So we're also going to want the expectations for those. Expectations, introspection, platform features. Those 2 and that one. This one is for a different configuration. It's when we're configured, so I don't want that one. Okay, so we've got some expectations. Let's have a look at what we've got in there, shall we? So if we just refresh that. Ooh, that's interesting. Right, so we've now got some expectations here. So we've got platform features that's going to print out some things. We've got code features that's going to print out some things. And we've got describe CPU that's also going to print out some things. So we need to build that code and then run it as part of our tests. So let's just build the module, and then we have to remember how to do the testing. So we look in the test code directory. We do this to build the code. Come on. Thank you. That's building cache info, code features, and describe code CPU features. Excellent. They're now built. And then I want to go and edit the test descriptions. So we have a look at the test descriptions here. We can look for platform features. So these test descriptions are my own format, and they say what is going to get run. So what we end up with is, let me just describe them. So you've got a group of tests, which is basically a collection that all goes together. Command to be run. So we run the tool with a file and some arguments, and the file is actually specified in each of the tests. And we've got an expectation that pulls out the base name of the file to be put into there. And by default, all of these are marked as not implemented, and we disable that disable to make it work again. And then you've got individual tests, all of which inherit the group definitions. So they inherit the command, the expectation, the disable. So for osbyte 0, we're running this file here, bin osbyte 0, and then we're actually using a slightly different, we're using a replacement file, so we get rid of some of the differences between systems. And it returns an error in this case, so we say RC is 1, because when you request the version, you get back an error code of 1. An error block comes back. So we're going to do the same thing with the platform features. If we look down here to platform features, we've got a test here that's for the code. So just remove the disable option from that. And code features configured, we leave that on there, disabled. Pyromaniac only. This one, however, we can disable the disable. And CPU features, we can disable the disable. There we go. And then we run the tests. Do we just do make tests? We do. That's cool. And now it'll go and send that test file and the binaries. Ooh, and the binaries. Is it going to send them all? I think it does. It sends them all to the build service to run them. And they'll start up and they'll run those tests and return the output. And the output is then compared against the expectations that we've got in our expect directory. So hopefully, once it's finished running the test that we've already got, we'll be able to see these platform features working. They will be slightly different because I think we've returned all the platform features for 32-bit. Just because we can. Oh, this one's now got a proper error code because we did that before. That's important. We'll fix that. And this one's got a lot of differences here. So instead of saying, IQ triggered necessary. We've now got not necessary. Has separate caches. All the flags are set, basically. Ooh, cache information failed. It actually returned not implemented. That's not right, because we should be returning that properly. Let's have a go at look at that one then. Oh, so cache level 0 has come out okay, but cache level 1 has said no cache. Ah, is that how you enumerate them? You enumerate them until you've got no cache out of it. That's interesting. And Andrew as well, who saw a post on that. So clearly I should be posting onto the forums to say that it's starting. As I said before, I wasn't doing that because I thought, people will know and they'll feel it's just noise. So maybe I should do that. This is coming out because of the debug I've left turned on. So I need to turn that off. But otherwise, this is looking the same, which is good. So right, let's turn the debug off first, because that's something that's broken or breaking things, I think. Turn the debug off. Okay, we can rebuild that in a second. Oh, kids are off school. That's why it's confusing people. That makes some sense, I suppose. Right, so this one, here we go. Yeah, so let's do this. Zero. No cache. This is the end of the list. That's quite a reasonable way of implementing this, I think. Delete all of that, and the spaces at the end, and then turn those all into zeros. There we go. Oh, I've got 2 spaces on the end there. It looks untidy to me. In the list. CPU features. Oh yeah, you can't. I could do that for 32-bit, but 64-bit would be impossible. And then we'll generate that table later. Right. cd.make. So we'll build the ROM, build the module, I mean, and then we'll do the tests again. Oh, I also wanted to change the expectations, didn't I? Because one of them was returning the invalid error. Yeah, that is actually correct now. So I'll put that in there. Was there anything else I can fix up? No, they look okay. Okay. I think I've got an option in the code to actually skip, to only run certain ones. Make file in test code. So is there a way of doing that? Test args. Yeah, so I can specify test, and that'll give me an option to run a specific test. I can probably do that. Right, here we are. Right, that one's come out differently. Andrew asks if I've got any plans for Christmas. First one as a married man. So in-laws are leaving us alone this year. It's our Christmas for us to spend together on our own. So we are absolutely just being ourselves. There will almost certainly be calls to people on and around Christmas, but largely it's what the heck. Sorry, you confused me a second by saying concurrent viewers 562. That's utterly baffled me. Skip. Hello to any new viewers that have turned up. That is just surprising, and I don't usually get a sudden influx of viewers like that. Wow. Yes, so that is my plans for Christmas. We'll be, hopefully we'll be. I don't know where they're coming from, but welcome, people. We are doing some coding on RISC OS. We are running tests to make sure that things are not broken, and actually they're doing quite well. We've only got one failure, and if we have a look at it, just give me a second to add the expectations that we had. So these expectations are all good. Oh, don't do that. Stop it. Having upgraded the OS, it's a little bit weird at the moment. S and bin. Right, there we go. So we just rename this one file. What we should be able to see is the diff on this. No, not that. There we go. So this is showing us what's actually different between what I was expecting and what was there. So yeah, we're returning lots of flags set just as a fake value on the 32-bit version. I think we'll just leave it as that, but that looks good to me. Status, commit everything. Yeah. Added tests for the new OS platform features 0, 33 and 64. Tests are now run for the 32-bit OS, and we can see that they return semi-useful values. Ooh, values even. Thank you very much. I'll push that and we can have a look at it. So if we have a look over here, is this the right window? Nope, that's an hourglass. Is this the right window? This is the right window. So in case anybody is missing this and wants to follow it live, this is the repository. We go to actions and we can see the action running and that it's starting to run, and it's failed. It's failed. Why has it failed? What have we done wrong? Oh dear, that didn't work. That's my make file down here. We need to tell it to depend on that header file. So let's fix that. Platform features. Commit -a. Fix for failure to build OS platform. Oh no. C/OS platform features. Dependency in the make file. Push. Off you go. And then we'll go back over here and have a look at the action for this one, and we'll cross our fingers that this will work. Yeah, like and subscribe. That's what you're meant to say, isn't it? I don't know. I just do this because it's fun. I'm really not that worried. Although that said, I am considering setting up some GitHub sponsorship on these things so that people can do things and give money to me if they're interested in seeing more of the same content and encouraging the things that I'm doing. So we might I'll talk about that at another time, but I've been playing with the idea and trying to decide whether to do it, because it's not so much like the money is needed, but it's more a case of this is fun. New Amazon TV live coding game show. I don't think that live coding is going to become a big thing. Gerph brand protein bars. Now there's a sponsorship thing we should be doing. Yes. And now you've said that, I'm hungry. That's just. Oh, did that fail? Oh no, it passed. It passed. Tests are passing. Woohoo! Ship it. Actually ship it. That's not a bad idea, is it? Let's ship it. Let's not ship it actually, but let's go and mark the things that are working, because they are working. So vmanage increment the version number, commit -a, things increment version to 0.02. Things are working, so let's do a release. Push that, tag it v0.02, and then push that as well. v0.02, push to origin, isn't it? There we go. Yep, we're going. And then make sure it builds. I should make clean first and then make it build, shouldn't I? And then build. Thank you. And then repeat for 64-bit build. Sponsoring for Gerph, that is an interesting idea. Well, it's partly because of suggestions that other people have had on the forums about doing things themselves, and it's like, well, yeah, I could do that. I'm not really that fussed about it, and I'm not doing it for money or anything, but it could be interesting. It would at the very least mean that people would be able to show some interest in this rather than just like going, oh, that's nice, which would be quite cute. I would quite enjoy that anyway. Right, so let's move these built binaries and then we'll update the status repository. So we're going to the status repository and we can have a look at, oh, stop doing that, will you? It's putting my new Windows on a different workspace. I don't know why. I don't know if anybody else has seen this on Tahoe or not, but it's quite frustrating. Oh no, I know what it's doing. It's spotted that I've already got this window, this directory open, and so it's like pulling that to the front. That's need to think on that. So was I leaking information about for Talia there? Damn it. Oh well. Yes, and I was listening to Ace of Base because I got an earworm in my head earlier from watching. We watched The Roses last night, and I had something in my head that I can't remember now, and I'm going to try and keep it that way because otherwise I'll be humming it all day again, and I'll get slapped by Talia because she was saying, "Can you just put something else on to stop it?" Yes, I'm using Clementine as well. I like Clementine. It's quite a nice, music player. Sorry, I'm also completely thrown by what I'm doing now. This is all very, very confusing. Yes, so we're looking at kernel introspection markdown. Here we are. So what have we done? I'm gonna. So what I was going to do was going to mark these as stubs, wasn't I? And then we can actually have them as real values later. So let's do that. Let's have all of these copy, paste. No, let's not do it that way. Let's put them next to one another. So all of these, line edit, copy them, paste. Ooh, no. Paste them. That's not quite what I wanted to do. What have you, oh no, what have you done? It's pasted it onto every single, oh no, no, stop it. Should we try that again? How do I, I'm not sure why that didn't. Copy each line, paste line, return. There we go, that's done better. So now I can add in here that they are a stub. Okay, I'll put them put it afterwards. There. Then we can mark all the ones that are stubs as stub not done. Stub. No. This is going to get tedious, isn't it? Go back to the space. There we are. Gets rid of that. And we can do the same for this. And then we can actually mark them down as being stubs. Stubbed. Stubbed. There we go. That'll look nicer, won't it? And then the actual implementations can be marked when we actually get them complete later on. Oh, actually, they're not done. They're not done, are they? I haven't completed those ones yet. Enumerate footer entries. No, that's not done. But I have done all of these. Copy, paste, return, stub. There we are. So now we can mark these with stubs. Code features is done. That's not. Should also be implemented for 64-bit as well, because we did that. Cache features is stubbed as well. And CPU features wasn't, but registers was. Actually, registers is implemented properly as well. It's a bad implementation, but it's implemented. I am never going to be using VI, I'm afraid. Horrible thing. So Arctic says, how do you actually make the kernel? So the kernel work will come later. The goal of this is to do all of the other bits at the far end, and then the low end part of the kernel, the actual starting up, will come to later. I'm expecting... My personal thought is that around March I may have something more worthwhile to show. But a lot of this is not so much designed on getting the kernel itself up and running, but getting all of the bits that the kernel is going to use later, so we've actually got a lot of things working. Because I don't need the kernel right now, because we can use it with the current system. And a lot of these things can be made to work on 64-bit for Pyromaniac, and 32-bit for RISC OS Classic and Pyromaniac. That's the sort of way that I'm approaching it. It's a little bit about face, but it's very similar actually to how Acorn originally did their operating system. So when Acorn designed the chips, they did some test versions, and they got back the chips from VLSI, I think it was from they got them from, didn't they? And as I remember, they went and, as I understood anyway, I wasn't there, but as I understand, they built them into the tube, which sat on the end of the BBC, and they used the BBC as the visualization how to do things, and then put everything slowly onto the tube environment so they actually could run it on the ARM. And that meant that lots of people could develop things on their BBCs and produce the actual code, and then they would test them out on the real chips without having an operating system really that was running. And if you see any references to what Acorn referred to, or ARM referred to as semi-hosting, that's what it comes from. It comes from the tube environment, because all of the system calls that were used in the ARM side were actually just being fed through to the BBC to display things and read information from various ports and all of the other parts of it. So anyway, yeah. Yes, Timo remembers that it was VLSI as well. Thank gosh for that. Right, so we've also got these SWI calls implemented here, and vectors, no, nothing else. That's our lot then. So we can now commit that. Diff. Yeah, there we go. XYZ. Update for the kernel introspection. We now have some OS platform features. There we go. And if we push that, we should be able to pop over here, and this is the kernel inspection page. And if we just wait a moment for it to populate things, we should be able to reload hasn't updated it yet. Either that or I got it wrong and it's not working. Go on, update now. Yeah, there we go. Functionality 22%. A little bit fake because we have added some extra bits in there, but we've now got the stubs actually marked. I haven't marked them for the 64-bit because I couldn't test them on that, but that one we did test, so that was okay. But we'll add some testing in for those. Yeah, we didn't test that, but I know that works, so I'll be happy with that. So there we are, we've got those bits up and working. So next bit to have a look at is probably going to be OS memory. We'll start putting in some stubs for that, but it's time for a short break. Go and take a little bit of a time to go and grab a cup of tea, and be back in about 10-15 minutes. Okay. Drink time. Yes, it would be. Oh, I have got some pineapple juice. Ooh, but I don't think it's in the fridge. So anyway, see you in a mo. Hello, 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 and welcome back. It is nearly 3 o'clock. We're a little bit late today because I was getting carried away on doing platform features, but we are making good progress in this. Hopefully we'll be getting a bit further. So what we've done so far is implementation of, we actually show stubbed versions of the RISC info implementations and some of the platform features implementations. We need to do some OS memory calls and memmap info and memmap entries. I believe memmap info is the nice, easy, simple one, and entries is the big bitmap table. So we'll have to have a look at those and have a see what we can do. Is there another one? There's OS memory, and that's it. Yes, OS memory is oh, physical table. That's the one that's actually got the bitmap in it. I'm not sure what memmap entries is then. Yeah, we'll have to see. And IO space is going to return me as pretty much 0 for most things, I think. No, amounts is going to return 0s, and IO space is going to probably need to return some pointers to memory, but we'll need to do that. Yes, so which one do we start on? Let's see what memmap entries does. And then we'll have a look. So RISC OS PRM. What do you mean no? Oh, is it read memmap entries? It's read. Oh, I've misnamed it. That's not ideal. Well, since I've misnamed it, let me just quickly fix that. See, it's there. It's named properly there, just not here. Read. There we go. We'll fix that up in a minute. So there's the link we want. Copy that over here. Paste. The returned list is a series of entries, 3 words long, terminated by -1 in the first word. A series of entries, 3 words long. So yeah. And then memmap info, I think, tells you how big that is. Yeah, page size and count. So there we go. I mean, none of this will actually matter for RISC OS Pyromaniac, but for a real system, we'll be able to use this. Actually, this has probably got a different interface in modern systems as well. So we'll implement something, and then we can work out what it's going to be. So yeah, hopefully we'll be able to make that look similar. Yeah, let's give that a whirl then. Starting out with that, so let's get out of the status stuff and start looking at adding this in. So we're going to add OS memmap, we'll call this. Since I forgot last time, let's put it in here as well. OS memmap. And then we need to define the system calls that we are going to implement. So here we are, entry points for these. And there's 2 of them. Yeah. So read memmap info. Read memmap info. And read memmap entries. Read memmap entries. Okay. See you later, Alan. Have a great Christmas. Enjoy yourself. And anybody else who has to leave, also enjoy your Christmas as well. I realise it's 3 o'clock, so you may be heading off. I'm going to be doing this until about 4-ish, but I have other things to do this afternoon, so I won't be doing too long. Hopefully, won't be doing too long. Right, another one here. Read mem map. Mem map. Info for the top one, and entries for the second one. There we go. Put some commas on the end of these. Okay. So now we can go and build that, and it will then tell us which bits we've not done. Oh, we're not even. Yeah, we haven't got a file. That would definitely do it. So, yep, new file, os mem map. Thank you. Os mem map. Interfaces to the memory mapping subsystems. Okay. Include mod head. Which, probably want to include studio and studlib, and we also want to include what else should we include? Kernel.h. Right, so that gives us those bits. We also need to pinch the bits from this one for debug. There we go. And then we'll build it and see what comes out. Yep, that's our entry points all not working because we need to also add them into module. Go. Read mem info. And entries, and repeat in the other. It's a little bit tedious, the repetition here, but it's fine. Info. And memmap entries. Oh, memmap info again, and then entries, sorry. Oh, I've missed the read off, haven't I? Timo said I type a lot faster. I also make probably a lot more mistakes than most people. It is a true fact that the more eyes you've got on your code, the more mistake you make. So with lots of eyes on this, I'm going to make lots of mistakes. At least I believe that. Look, that's just very broken. I don't remember even typing that wrongly. I think I must have hit a page down or something at one point. So I see. And now the SWI calls aren't implemented, which is correct because we need to pinch one of these. These are actually quite simple, aren't they? They don't have anything other than a simple entry point. So here we go. Read mem map info. Return and another one for read mem map entries. Now I don't think we have any of these in Pyro. So let's have a look in OS memory. OS memory, that's actually an implementation of OS memory itself. Oh, read mem map info. Huh, we do have that. So there we go, we've got at least one definition in there, and we always return the same values. So very, very simple here. Null alt r bracket 0 uint32t page size, uint32t n pages. Page size, pages. There we go. So that's memmap info implemented. It doesn't do anything useful because both of those are empty now. It's going to come out unhelpful there, but doesn't matter. And the second one is read memmap entries. Now this is more complicated, and we don't have an implementation of this because there aren't pages on RISC OS Pyromaniac. So we're going to have to return this, describe this one better. So let's just describe it. OS read memmap entries, read the details of the page tables, page entries. This is actually a really unuseful call because you can't get enough information out of it. But it is obviously there for compatibility. If def RISC OS 64 not implemented. Else. No. So there you go. Won't happen. Won't do anything in 64-bit, and in 32-bit. See what we can. Pointer to table to populate, and that's it, isn't it, for inputs? Yeah. Pointer to buffer to receive list is there, and then on return, all preserved. With a series of 3-word entries terminated by page -1. So +0 contains page number numbered from 0. This is logical page number. +4 contains logical address. +8 contains protection level. 0 RW, 1 RO in user, in others, 2 and 3 no access in user. That's the definition in the PRM. It may have actually changed in other parts of the in later versions of the OS. For now, I'm just going to leave it at that. Right, and we're going to want to do yeah, we should really have this as a type def memmap. This is mem entry, isn't it? Memmap entry s structure page number uint32t address, and then uint32t protection. There we go. Memmam entry. Move that up here outside the function. And what we'll do is we'll just return. So we do Memmap entry t star memmap equals map. No, not st, please. Why would you ever? It's not matching it because I got a typo in it. Star r to r bracket naught. Memmap to page number equals memmap no page. No page number, I suppose that should be. There we go. And then that's actually a valid table, even if we're not returning anything useful. That should now be consistent, I think, which is good. Right, build it. That wasn't very good, was it? Memmap entry. Inventing int memmap entry. What are you complaining about? Sorry. Did I? Memmap entry t. Oh, this hasn't defined anything. Oh, because I didn't include student. You see, you have to read all the error messages, otherwise you. There we go. Build better. Right. So it's still saying inventing memmap entry t. Type def struct memmap entry memmap entry t. Copy. Oh, there was something different there. What did I miss out? Oh no, I've got an extra M in there. Mentry. That's why. Mentry, yes. See, Dave spots things. There's a 10-second-ish delay between me doing things and people commenting, I think, or the video appearing. So it's just introduced by YouTube, I think. I don't think it's my end, but it means that I can at least spot things and then people comment them. All right, yes, you got it probably before I did. But it's built, woo! So we should be able to now enable some of the tests for that. Let's try some tests, shall we? Read memmap info. That looks like it's got a test in it. Disable off. Oh, YouTube keeps locking Dave out of live mode. That's even more weird. Although I did see that on some things myself when I was watching live channels before. It can be very confusing. So, read memmap info. We now need to go and do the move things over. So, read memmap info. That's the test for that. Or is that expectation? Or that's expectation for that. And we want a test as well. There should be a read memmap info. There we go. Read memmap info test. I haven't been looking at what's in these tests, by the way, and that's intentional because they're all written for RISC OS Pyromaniac and they just work. So we just get on and use them. But I'm in the wrong directory there, aren't I? Look, this one. See test code. But we can have a quick look at those. So if we have a quick look at read memmap info, just for fun, so you'll see that this is a very simple thing. We use there's a header for SWI entries, so there's a SWI's file that contains all of the SWI numbers. That's just been converted automatically. That's quite easy. It looks very similar to the one that's in RISC OS itself, RISC OS Classic. There's these print macros, which are very simple. We can do printing integers, printing signed numbers, printing hex. We give it the register number and then the width we want it to put it into. And then that can mean that we can line things up. So for example, the number conversion here moves some registers around, sets up a buffer, put some negative number on there if we wanted it, converts the value, and then prints it out. And then if there's a width specified, it pads up to that width and restores the registers. And same goes for strings and other calls that we've got in here. So there's a number of different calls in there. And these are all like publicly available, so anybody can look at them and change them and update them and what have you. That big bit table that we used was built by one of these print bit char things. So it does some quite nice printing out with the named bits here as well. So we've got some nice interesting ways of drawing things. And then there's some general macros that do XY that lets us pass some registers in, XBL which allows us to do branches in the same form, and then we can push and pull, and there's also an entry and exit I think as well. Got entry and exit? Yeah. Entry and exit here somewhere. There we go, entry and exit. That set up registers, and they're very similar to the calls that are in RISC OS Pyromaniac, not Pyromaniac Classic even. These are XY and XBL implementations that set up different registers for parameters. They're very, very simple. When you have a look at the actual code here, we do a print out a line, which is just a write S. Then we do call the SWI, print out some text saying what was the size is, what the page size is, print the integer value, and then do a new line, and then repeat for the next word. That's it, pretty much. It's not all that complicated, but it gives us a vaguely useful set of outputs and relatively readable code, which is nice. It also means that because I've got implementations of these in ARC64 as well, the test code that you would use for ARC64 is almost identical. It doesn't have very much difference in it. The only difference that would be present in it here would be the register number would be called X0 and X1, and this would be a RET instruction. That would be all we'd be doing differently. Yeah. Anyway, that's what this particular one is. I mean, the other ones have got more things. So describe CPU registers has got some definitions, calls the SWI, and then does a loop over all of them to display what the definitions are and how they're laid out. So there's a lot more work involved in this one. When I come to port this to 64-bit, I will write a similar test in assembler, and most of the code that I will be doing for testing will be in assembler. The reason for that is I don't want to get confused by what the C compiler is doing and other bits of C library things in the future. So that's what we'll be doing there. However, in the meantime, we are just trying to get this memmap info call done, and I could have left it running whilst I was doing that random wittering, couldn't I? That would have been sensible, wouldn't it? Oh well, it can run now anyway. We get memmap info working, then we can potentially create a memmap entries implementation as well. In fact, we can probably do that. Yeah, I'll do that in a minute. We'll create a memmap entries. Oh, let's do it whilst that's running because it's boring sitting there watching it. New file, read memmap entries. And I'm going to start from this one because we need to call memmap info to work. Oh yeah, you need to call it. No, we just need to know how big the block is. This is a utility file, so it's not going to be using application space. That's handy, isn't it? Because that means we can do memmap entries. And here you go. Here's an example of doing it that way. We pass in 8,000. Hello. Merry Christmas. More people joining us. So memap entries, the table looks like this. So +0, ooh, that's finished. It's finished and it returns, oh, page size 0 and number is 822. It's not actually useful to return a page size of 0, is it? We should, if we're going to fake this, we should at least fake it with something that's vaguely sensible. Yeah, page size 4096. Make these abstractions. We'll do that later. There we go. And then we'll rerun the tests. Okay. So yes, I'm implementing read map entries. Oh no, that is info. Sorry. No, I'm in the wrong file. I'm getting myself confused. That's not assembler code. I want this code here. There we go. +0 contains page number or -1 to terminate. +4 contains the address mapped, and +8 contains protection level. So let's just go through the loop. RDMIA R1 from the table in R0, R1, R2 and R3. Print hex R1, no, print integer R0 and pad to 8 characters. Print in hex oh, not R0, sorry, R1, then R2, which is the address, and then pad to 12 characters, and then print the protection level, and we don't need to pad that one because we're going to go integer. There we go. And then we just want to print out a new line. Is R1 -1? If it is, we are finished. Why are my tabs not lining up? What is going on here? Those tabs are just not. Tab. Why did that not? That's inserting 4 characters all the time. It's not actually going to a tab stop. I'm going to have to slap something in the in this editor, I think. We're done, and at the end of it, go back to 10. Yeah, tab stops is not working properly here. I see you back from the coffee break. Yes. Sorry, that's terrible. Don't know how YouTube recommended this to me, but I'll watch it. It's fine. If you come along and you enjoy it, that's fine. If it's completely losing you, then that's also fine. I don't mind who my viewers are, so long as they're doing things they enjoy. Right. That test I was running is now complete, and we're happy with the output. Let's add expectation and add the SCOS map. Add, sorry. There we go. And the binary file as well. Oh, excuse me. It's not good, is it? Every so often I've been having coughs like that. It's not been great. I think it's been getting better last week or so, but I'm not sure. Right, make our test code. Unknown opcode. Oh, I didn't include macros. There we go. Build that. I think that built. Oh, I was building the wrong thing. There we are. Right, and then we run it. Let's just try running it and see what happens. Actually, I don't even need to, do I? I can just go bin/read memmap entries. So here we go. So this should return an error. So why not know? Because in RISC OS Pyromaniac it doesn't exist. But when we load our new module, RM32, oh no, RM32/new module, there we go. We should now get, load the C library as well. It returns nothing because there are no files in there. But what we can do, if we link this and put it into bin/read, that's the one, wpwd into /library application support /rpcmu hostfs. We'll just put it in the root of the disk, and then we fire up rpcmu. I don't think I've run this since I upgraded the OS. Apparently I did. It's, well, maybe I didn't, but it still works anyway. Right, if we have a look down here, where is it gone? Read memmap entries. So we can open a terminal. Thank you. That's not doing it. Why is it not? Control F12. Thank you. Read memmap entries. Woo! That failed. Why did that fail? Does it not have enough memory? Read memmap entries. How interesting. You know, that looks rather broken to me. Is it possible that my version of select is actually buggered? It's quite possible. That doesn't look like a valid entry either. How interesting. It may be that I broke it in Pyromaniac. How bizarre. Okay, so let's try RISC OS 3.7 instead. So let's jump out of that. Oh dear me. Just give me a second. I've got a command down here somewhere that I can use. Docker. Oh, yes, go away. Docker. RPCMU. Yeah, that'll work. There we are. And then we screen sharing. Ooh, that didn't start up properly. Give it a moment. It probably, sometimes it just times out and I need to give it a bit more. There we go. Time to start up. There we are. Thank you. That's nice. I'm glad I've got that working. So the what I've got working is the it'll resize the size of the VNC session to match the mode you're in. There's my new module. Don't want to load that. I do want to look at the test code. So where's test code? It's in bin. Huh. That's just reporting the same thing over and over again. For given page numbers. That's what it's wrong with it. You've got to supply it with a list of pages. It doesn't list you the whole of the whole of memory. That's why it was broken, because I was passing it 0 for everything. Okay, well that at least explains it. It helps if you can read the documentation. That's fine. Yeah, okay. So that means that what I can do, let's just populate it with mov. Why are my tabs not working? What if I did turn off tab stops, but that was because it was doing stupid things with delete. I'm sure I will find out what's going wrong. So move R0 and then store. Actually, let's start out with address 8000. Then we don't have to do this bit here because we'll, we will do that actually. Mov R1 comma number 0, store R0 R1 R0 number 12. Yeah, that's right. And then page 1, add R1 number 1. There we go, that's enough, I think. R1 minus 1, and then terminate our list. So that'll come out a bit better. Yeah, I think that will work. So, what I can do is open a new terminal, build make even, and then we can pop back to here and run it again. There we go. Page 0 mapped to there, 1 is mapped to there, 2 is mapped to there, and 3 is mapped to there. And they've got protection levels that are not even vaguely the same as the protection levels it says it should have, but that's because I think because of RISC OS 3.5 onwards. Anyway, that's working. It's actually doing the right thing there. In our tests, it'll be doing a different thing because test equals mem map entries. I think we can do that. Oh, do I have to say star mem map entries? Quantify, oh no, it's a regular expression apparently. Dot star. Entries. That isn't working. Why aren't you working? Is it not called that? Oh, because there isn't a memmap entries one because I haven't added it yet. go, and we don't want it disabled. So let's try that again. There we go, now it's found it. And it's returned as an empty table, which is correct at the moment. So what we'll do is rename that to the right thing, and then we'll add them in. Expect. And then if we jump back to the source code, I can actually make a note of the fact that this is wrong. Table to update. The table. Yeah, those tabs are not working. The table contains 3-word entries. The first of which is a page number terminated by -1. There we go. And we're just going to say here, fix me, we are just reporting no pages at all. Okay, there we go. So the entire table is just garbage at that point, but we've at least got something. Right, status. Add stub implementation. Oops. Nothing useful at all. So there we go. That might be a little contradictory, but I'm going to just go with it because I'm not caring. Right. So that's read map entry, memmap entries, and the other one, read map info, returning things. Next one is OS memory. Do I have time to do that? I've got 20 minutes. Yeah, we'll just have a quick rattle at that one. It probably won't be very good, but we'll just do something. I should have probably done find memmap entries in there as well, but since it's very similar, but doesn't matter. OS memory. Interface to control memory. And this is going to be very similar to the other ones, so I'll just pinch the headers from this. Might as well. And then we update this, don't we? Memory. Memory. And there's another one here, isn't there? There's this one here, yes, that's right. There we go. Comma on the end of that, and then build it. Yep, that looks okay to me. I just need to implement those calls down here. Here, this is the one. I know what I'm doing. Oh dear, no, that's not what I'm doing. copy, paste, paste. Memory. There's been a lot that I've done this year that's been produced some quite useful bits of code. Like this particular section of registering the OSWise is entirely reusable by anyone, so it could be put into anybody's module, which is quite handy. Well, quite handy if you happen to need to replace an OSWI, I suppose. Let's I'll copy the body of that, and we'll just modify it to. Oh, it'd probably be better actually for me to modify one of the ones that's got reason codes, isn't it? Let's spin to the end of this. Yeah, with the switch in it. So here we go. This is a better one to do, isn't it? And then at the ends, default not implemented. Oops, what did we just do there? Copy, not paste. There we are. Memory. Platform features should become memory. And then we add it to the make file as well. And remember to add it here. Build. Oh no. Build. Cool. That built very quickly. We're going to want to include RISC OS /h /os memory.h. I think I've got a header for that. Let's have a quick see. OS memory. Fine. Yeah, we got loads of them. That's cool. So these reasons are the ones we're interested in, the ones at the top here. And we're going to want to paste them into here. Oh, yes. Lots of entry points. Case. OS memory. Oh, no, I didn't mean to do that. I pressed end by accident. No, didn't mean to do that. I'm going to press that. Break. Copy that. Equals. Lose the word reason out of that. And all of those lowercase. So. And I can probably get rid of the ones that are marked as reserved because we're not going to implement them at all. But since we are here, let's just copy all of this. No, let's not copy that. It's not going to work, is it? I'm going to want that list again. Copy, paste. Yeah, so there's 13 to 16 is reserved, 17 to 23, those are all reserved as well. So we don't need any of those. Let's kill that. That one, those ones. Kernel os error star. Yes. Reason. Lowercase. Kernel swy regs star r. delete those. Kernel loss. Star implemented. There we go. All of those are now provided. We can now get rid of the ones here that we've got reserved because we don't care about them. Reserved. Recommend page not implemented. Reserved. Valid address. And physical spaces. Okay. Did we have a bad OS memory? I can't remember. New errors. Yeah, it doesn't look like there's an OS memory one there. So we'll just return the not implemented for now. Can work it out properly later. All right. So we've got a few that we can implement here. If we build that, it should come out as a... Yep, good. Which ones are the ones that we care about? So I've said OS memory here. I want 6, 7, 8, and 9. Physical table size, physical table, amounts, and I/O space. Now amounts, I think, is quite fun. It just so happens that I have OS memory on the screen in Pyromaniac here. So we can actually copy the comments straight from them. Let us do that. 6. Read table size. Seven, read physical table. Now this is, I think, physical table is broken in RISC OS 4. Yeah, in fact, it makes a note. It doesn't seem to work properly on select. It writes more data than it claims into the table. And I'm not sure why that is. I don't remember manipulating any of that code, editing any of it, but yeah, maybe I did. Clearly I did at some point. It's got different reason codes there, fair enough. 8, this is amounts. Yep, that's this one. I/O space. Read controller presence and base address. All of this should be replaced with a table-based system. That says what controllers are available, what chips are available, what addresses in physical memory, and any other details that they need, like you would have on a x86 system. And that should have been done like years ago. Not quite sure why I said it that way. Lock free pool should entirely go away because there should never be a free pool. The whole concept of a free pool is just quite nuts, really. Recommend page is quite useful, but can be handled differently, I suppose. Validate address is vital for many operations, so we're going to need that one. In fact, I say it's vital, but I don't see an implementation on it. Validate. Yeah, validate address just isn't implemented in Pyromaniac. How weird. I'm relatively sure that it's actually relied on by things. Except, of course, it probably is relied on by things, but it's only relied on in the sense of if it's there, it will get used, and if it isn't there, it'll get it'll revert down to the OS validate address. Is there any reason why RISC OS never supported virtual memory? Disks were slow, and the window manager's development was not very sensible. So implementing virtual memory requires that the kernel really be able to manage that, because otherwise you're building Windows 2, possibly Windows 3. You then end up with a system that is a little bit more tricky to work with. The problem is that the window manager manages task memory, and that's wrong. So any virtualization system would have to be built in potentially into the window manager, which is not a good design. Alex Thukydides, however you pronounce his name, I can't remember. He built Virtualize, as Dave says, and I believe Virtualize is that dynamic areas only rather than... No, it did do application space, didn't it? And there was, I think there was a RISC PC version and a non-RISC, an Archimedes version, because I remember using it on my A5000, one of the implementations of that, and it was quite useful, but disks were slow and you did have a number of problems with it. There was also speed. I believe Noel Douglas's speed, which improved things in RISC OS 3.6 particularly, also had the ability to go and page things out rapidly. But the difficulty is, of course, that not only did you have to contend with the misdesign of the kernel, WIMP, application space, rest of the system, you also had to contend with the fact that aborts were not safe. You couldn't necessarily abort in any system call where you're in supervisor mode and be safe, because R14 would be corrupted. And until ARM6 came about, there was actually no way to handle that. And of course that then also became worse because the strong arm introduced problems with aborts at certain address offsets. ARM7 had some problems as well. You'll notice in the discussions we had earlier there was a flag for abort so early or something. So in ARM6, I believe it was, you had the choice of whether aborts were early or late, which means whether it was after or before the base registers were updated. And of course, if you're trying to do a more complex operation, like an LDMIA that spans across a page, have you populated those early registers first? Have you populated the later registers first? I mean, because strictly, the ordering of loading doesn't actually matter, because it might do. It may actually be defined to be sequentially upwards, but that could have happened if you were, for example, trying to load memory in the lower section and your register was updated, like R1 exclamation mark, R12 exclamation mark, whatever you were using in the LDMIA or equivalent, then you could find that you actually have no way of getting back to the original registers. And that was a problem with, I believe, ARM6. I think it's later aborts that are bad, early aborts are better for that particular purpose. But basically, the operating system badly designed, a belief that the WIMP is a good place to have the memory management. Maybe not a belief, but that works. It's not meant to. It's insane. Let's go with it, and continuing to go with it forever, as is currently the case, has caused problems. Architectural problems with the processor and the difference in the operations between systems, and then disk speed early on just wasn't worth it. Remember, early systems were also floppy disk based, so you didn't really have many hard disks. I remember my first hard disk was a 80 megabyte drive, and remember thinking how amazing it was that I could put most of my floppy disks on the hard drive. As time's gone on, it's been more relevant, but of course RISC OS isn't designed for that. Assuming that you can page out memory when the thing that you're paging out has to call another system call whose reentrancy is not defined, could cause you problems. So an example might be, you wish to page memory out to disk. Your disk is implemented over freeway, over ShareFS, which is over internet. So you start paging the memory out, and because of somebody accidentally doing something, the internet module then issues an upcall to say, you can preempt me now because stuff's going on in the internet stack. At which point you're then in the middle of paging memory out, memory isn't quite valid, and you're potentially switching to another part of the system because, of course, task window. The whole application model does not really allow for this sort of work in a sane way. There are a number of different things that you can do. If you assume that it's not going to be code that's going to be paged out, things get a lot better. If you do it in dynamic areas, a lot safer. I believe Virtualize did its work by emulating most of the SWI calls. So when you did a load, for example, it went, you're going to load this, I'm going to open the file and then do small chunks of operations until I hit an area that needs to be paged in, and then I'll page it in and then do the next bit, and like that. It became very, very painful, all because it's not designed into the system. Yeah, that was a long rant on why I think virtual memory was never supported. Application model, bad design, bad implementations of CPUs, and design of the CPUs. I remember that there was a number of workarounds in Linux to handle those cases as well. It's possible my recollection of that may be wrong, and there may be other reasons why it is, but please feel free to suggest any other reasons and the like in comments on rule forums, because there's a lot that could have been done but wasn't. Right, anyway, I was in the process of doing this OS memory call. I don't think we're going to get very much more done because my ramble there has taken us all the way up to 4 o'clock. So let's just get that committed, and then we'll leave it for the day. Yeah, I think that's probably a good idea. Add .c/os memory. Did build, didn't it? Oh, I'm in the wrong place. Yeah, built, and 64-bit as well. Dear me, fingers not working. 64-bit. Go on. Yeah, that looks fine. Add stub implementation of the OS memory. There we go. Push. Okay. I think we are good for the day. I think we're going to leave it at that. We have done a reasonable amount. If I just pop back to the status, we can actually update that a little bit. Here we are. So we can just update this to say that actually we've got stubs for both of these implemented. Oh no, on the other ones I put the stub first, so let's do the same. Stub, and the actual SWI calls are implemented. This is good, and OS memory as well. So all the SWIs are now trapped, even if the actual implementation behind them is not complete. And that's about it really. That's all we've done. Okay, well, fine. Oh no, of course we've actually got stubs on these, so let's just paste. Stub. Yeah, we've got a stub for that, stub for that, and stub for that one as well. There we go. All right, commit that. Push that. Okay, so with that we have probably not a huge amount actually implemented, but we've got enough stuff to start hanging things off. All the SWI calls are in place. It's just the stub functions that we need to start filling out. Next week there won't be any video. We won't be doing live coding, so that's the 28th. Well, maybe we will. Maybe I will. I'll make a decision later this week and try and decide, because I'm not sure that I'm going to do it then. I think I'd wanted to, but I'm not sure I feel it now. We'll see. If there's nobody around, then it won't really matter. I'll just be talking literally to myself. But if you aren't there, I'll try that again. If people aren't around, have a good New Year, and for now, have a good Christmas. I hope you all enjoy the time that you've got for a break. I hope you've got a break, and try to be happy and bright, and drive carefully if you're going anywhere. All right. See you all later. Have a wonderful Christmas. Bye.